Hello everyone. In this video we're going to discuss about the newest technology involving the broadcast or multicast of OTT content over several networks, LTE, 5G cable, satellite, IP, etc. And we'll see how compatible this is with low latency. First, I'd like to introduce myself. My name is Bouqueau. I am a software programmer, open source, and standard contributor. I first worked at a video transcoder company called Allegro DVT, then Kipixo, then Anivia, and now bought by Atem. Then I moved to a research lab. And finally, starting in 2012, I have founded MotionSpell to support the GPAC open source projects, and I've founded several other startups. Please go on my LinkedIn if you want to know more. For our team, the low latency OTT journey has started in 2013 with a research paper that was accepted at prestigious i3E and an open source program to support our then groundbreaking claims that yes, OTT with our usual containers can go down to a 1 frame latency. We won't go any lower for today with these containers. And since then, we have continued to publish on this complex subject. And the result is that hopefully now, low latency is part of any new standard requirements, even if sometimes, as we'll see today, it adds some complexity. The current issue today is that for OTT, one user equals one streaming session. Over the years, we have learned to make it okay, even though this has a huge drawback. Distribution costs grow linearly with the number of viewers. But then there are some limits. With more users and more bandwidth per user, because we consume more content and we have bigger resolutions, we increase the pressure on the network with the risk of degrading the user experience. The solution would be to use legacy broadcast or IP multicast distribution. In these cases, the content would be sent only once to multiple viewers and potentially to an unlimited number of viewers, or the maximum number supported by the emitters. The solution envisioned by the latest standards, namely ATSC3 and DVB multicast ABR, is a hybridation of broadcast and broadband, where the content is either pulled from the CDN, as described here, and I will demo this later, or pushed by the encoder. The content is then sent to a multicast server, then transported only once to a gateway that receives the signals and make it available to the end clients. Technically, since we are talking of MPEG-Dash or HLS, we are transporting a local file system with all the files, the manifest and the media files. And this file system is updated dynamically in the live use case. It is transported over IP. And to transport the file system over IP, the most open and adopted system nowadays is root. And root has been adopted by both ATSC3 and DVB. On the right, you can see the layer technical stack. On the bottom lies the physical layers. On the top are the applicative layers. There are many advantages of transporting a local file system. First, we're agnostic of the transported files, which means that if there is an update on the applicative layers, or if there is a complete change of the files that we want to transport, it will be transparent. The second advantage, in my opinion, is that it makes it easy to have hybrid broadcast broadband applications. And this is an idea that is well described in the 5G standards. The third one is that we can leverage the upper layers functionalities, for example, encryption or low latency. And we're going to talk more about low latency from the next slide. But there are a few drawbacks. What happens if there is file system corruption, for example? Then there is some recovery mechanism, but it's complex. There are some files that are updated, so the local file system is updated, which means that we are continuously updating the file system. And to do this, we need to have a scheduler. And having a scheduler is complex. And there is a third point, in my opinion, that is more critical, which is that sometimes we will need to manipulate the manifest. With root, there are some low latency specifics. For example, in ATSC3, the streamer or the player should compensate for the distribution latency. Of course, there are some indications provided in the streams or the session that allows you to compute this kind of latency. In ATSC3, it is recommended to use the suggested presentation delay from the MPD. In DVB multicast ABR, we need to manipulate more closely the manifest. And it is more difficult to estimate the actual time because of this scheduling that I described previously, and which is a complex matter. Now, I'd like to take the time to make some experiments with you. And to experiment, first we need an implementation. The good news is that we have an implementation in the GPAC open source project. Part of this work was gently sponsored by Qualcomm. Our implementation allows to transport HLS and Dash content. The gateway can then restream the native format, so HLS or Dash, or restream in any output format that is supported by GPAC. So that can be MPEG-2TS, RTP, we can dump the session, etc. So we're going to see the different command lines to do this. And GPAC supports both the ATSC3 and DVB root flavors. To set up the server, we need an input content, of course. And there is also a special LL mode flag for low latency in GPAC. I'm not going to dig deeper into how GPAC works, but the -I and -O signal respectively the input and the output, and all in the middle are a filter chain intended to a magical graph resolver, because as you can imagine, the underlying processing chain is complex. So when using this LL mode flag, the input media segments are not reassembled in a single packet, but they are instead sent as they are received. Then the most usual use case is to expose the root content on a virtual file system as HTTP. So this is called a gateway. It takes root as an input and it exposes HTTP. And from there, the content can be played back on your favorite low latency player. And I wanted to show you the results in a player that's used in operations, the Dash.js player. It's a quite recent version, 3.1.3. And as you can see, the latency using a low latency source is about 1 second. Then I also wanted to share some additional command lines. I think that another use case from the industry is to take this content from the root gateway and to repush it to a CDN. In this case, you don't want Gpack to set up an HTTP server, but instead to push directly to your CDN. And you just have to use the hmode push option. The second use case is to repush the content as TS or as HLS. This is typically what you would like to do if you had a home gateway, like we have for SAT-IP, for example. You take the root content that you receive on a device inside your home, and you can restream to any device on the local network. And the third example is about dumping the session, which is really useful if you are receiving some ATSC3 or DVB MABR and you have a Dash or HLS player, but you don't have all the root stack. You just dump the content and you can play it back. There is more information inside the Gpack wiki with a how-to explaining more details than I did about using root as an input as an output. This is my final slide, but of course the low latency journey is not over. There are so many interesting things in this hybrid broadcast broadband delivery. The first point I'd like to raise is that in broadcast mode, low latency is safer because the signal is not going through unmanaged networks. The second point is that hybrid broadcast broadbands bring some interesting use cases, but low latency adds some challenges. For example, if you consider the scalable codecs, SHVC for example, that is referenced in ATSC3, you can augment your signal from HD with an enhancement layer to UHD, for example. But then with low latency, synchronizing the layers is challenging. Another use case that adds value is personalized advertisement. But then again, you have less time for bidding. Another use case is interactivity, where the low latency allows you to interact with your audience. I hope you liked my presentation. Thank you. And thanks for the organizers at Mile High Video who have invited us. If you have any questions, please ask.